In this problem, we've got this wire here. It's got a current going through it. It's sitting in a magnetic field, and we're trying to find the total force that's on it. So there's a couple equations we want to think about. First is going to be the FB equals I, and then DL cross B. That's just going to give us the force for each one of these components. But we need to do a couple different integrals. The first one is going to be from here to there, and then it's actually going to be the same thing from here to there. So let's try to think about that one first. It's going to be FB equals I, and then DL B sine theta, because it's going to be straight up, 90 degrees. If we were thinking about where the force was pointing, we could use the right-hand rule, point up, and we'd see the force is just going this way. It's cool. The same thing's going to happen here when we go through around this one. Force is going to be pointing this direction. So let's keep that in mind. And then we go over here, same thing, force will be pointing that way. So we'll come back to that in a second. But let's go over through here. In this case, the sine of theta is always going to be 90. So it doesn't really matter. We're just going to focus on this part. And for the DL, well, it's like IB, and then we're integrating across DL. Of course, the L is just going to be 0 to L. So, it's just going to be IBL here. And there's going to be two of them. So those two are going to be equal to 2 IBL. That's going to be it for that. We're not really giving any numbers here, so we kind of just have to do everything in terms of variables. Now we're going to need to look at this I section. It's a little bit harder, but let's also kind of take a look at the force over here as we move around. This arrow is going to point in this direction. And we kind of want to start noticing that if these two things were to, if got one side pointing this direction and then this side's pointing that direction, those two things are just going to equal 0. So the only thing left is going to be all the arrows pointing in this direction. There's actually tons of arrows pointing this direction, but all the x components are going to cancel. So we want to figure out, if we were going to integrate around here for theta, we want to kind of figure out what's the angle that we're going to be looking at. It would extend through here, and we're going to be getting this angle here. And we only want the vertical components right here. So how do we get that? Sine of theta is the vertical component, and then we got the F over here. So sine of theta equals Fy over the F, and then we could put F over here. And so now we know that we need to use the sine of theta. All right. So let's do the FB on this side. We're going to do I, and then this would be a ds. Keeping in mind S is r theta, and ds is r d theta. We can go ahead and use that. We'll say r, and then d theta. Cross that with the b, but this is going to be sine theta, so that goes away. And then we want to take our f, this is fb, and we're going to multiply it by sine of theta so that we get our fy's. Okay, so now we have this proper, because IRB sine theta d theta is an easy integral that we can do. And then this will just turn out to be negative cosine of theta. We're going to go from 0 to pi. And then we'll have an IRB towards the end over here. But I believe if I plug that into a calculator, we'll get 2. So for this answer, we get 2IRB. And all we got to do is just add those together. 2IRB plus 2IBL. And there we go. That's going to be the answer.